Hi, welcome to another session of Circuits and Networks. In today's class 12 under two-port networks, let us concentrate on dependent source problem, that is voltage dependent voltage source problem, which is also called as voltage controlled voltage source. And what we are interested to find out here, let us find out here the ABCD parameters, that is transmission line parameters, for the network shown in figure 1. So from standard equations of transmission parameters, that is V1 and I1, that is input voltage and input current, in terms of output voltage and output current, are framed as ABCD parameters like this. And we'll employ the actual approach, that is we have to open circuit the output port and later on we have to short circuit the output port. So when I'm going to take the output port and I'm going to open circuit it, I2 becomes equivalent to 0 and figure 1 changes to figure 1a like this. Clear? So V2 will be the measurement of voltage across 1 ohm. So we need to find out what is the current which is flowing in this 1 ohm. In fact, the same current it is flowing in 2V1 and the same current it is flowing in 2 ohms. Okay. So from the standard equation, V1 and I1 will be changed to AV2 and CV2 respectively when you are going to take I2 equivalent to 0. Fine. And I'm going to take here the help of Kirchhoff's voltage law. For that, I am assuming the loop currents in loop 1 as well as in loop 2 as I1 and I1 dash respectively. So from loop 1, we are going to get minus V1 plus 1 I1 minus I2 I1 minus I1 dash is equivalent to 0, whose value will be equivalent to V1 equal to I1 minus I1 dash. Let us treat this equation as 1. Now I'm going to employ KVL to the loop 2 where the current in loop 2 is flowing as I1 dash. So here you have 1. So 1 multiplied with I1 dash minus I1. Then after this drop, the drop across 2 ohms becomes 2 I1 dash. Then you have 2 V1 as it is, the voltage dependent voltage source. So I'm going to take the value as it is in this particular equation. Then you have 1 multiplied with I1 dash equivalent to 0. So from loop 2, we are going to get this equation and that we are treating as equation 2. Now, let us substitute equation 1 in equation 2. So we'll get I1 dash which is equivalent to minus I1 by 2. Let me treat this equation as 3. And substituting equation 3 in equation 1 will be giving you the value of V1 in terms of I1, which is nothing but equivalent to 3 I1 by 2. For convenience, I am treating this equation as 4. Also, if at all you observe, from loop 2, V2 is nothing but the measurement of voltage across 1 ohm, which is equivalent to 1 multiplied with I1 dash. But I1 dash from equation 3 is nothing but equivalent to minus I1 by 2. So substituting over this value, will be obtaining V2 in terms of I1, which is equivalent to minus I1 by 2. So equation 5 has frame. Now from equation 4 and 5, we have V1 equal to 3I1 by 2, V2 equal to minus I1 by 2. What is the requirement? Requirement of the parameter A, which is equivalent to V1 by V2 at I2 equivalent to 0. So here you can see you have V1 equal to 3I1 by 2, V2 is equal to minus I1 by 2. So in the denominator 2 gets cancelled, in the numerator I1 will get cancelled, so that A will be equivalent to minus 3. Since it's a game, it doesn't have any units. Also, we require C, which is equivalent to I1 by V2 at I2 equivalent to 0. So from this clear inspection, we are going to get the value of C, which is equivalent to minus 2 mhos, or you can have Siemens. So just now we have find out the value of A and C. Let me treat this equation as 6 and 7. Now our intention is to find out B and D parameters. For that, output port should be short circuited. Means what? V2 will be equivalent to 0. So figure 1 will be changed to figure 1B, which is shown in this figure. So here we have shorted the output port. Here we used to have 1 ohm. It is being shorted. Its value will be equivalent to 0. So no current is going to flow in 1 ohm. That is why we have replaced the 1 ohm with a short wire. And here we know that from standard equation V1 will be equivalent to minus VI2 and I1 will be equivalent to minus DI2. Now let us assume the current flowing in loop 1, it is I1. Also, I2 it is assumed to flow in this closed circuit in anti-clockwise direction. Why I have taken this direction? Because V2 is 0, but I2 it is flowing. So for easy convenience, I have taken the direction of I2 in anti-clockwise direction. With this, when I'm going to employ KVL to loop 1 and KVL to loop 2, what are the equations I'm going to get? So V1 will be equivalent to I1 plus I2 because minus V1 plus 1 plus 1 multiplied with I1 plus I2 equal to 0. So V1 will be equivalent to I1 plus I2. Also, from the anti-clockwise direction, I have minus 2 V1, you have 2 I2 plus you have 1 multiplied with I2 plus I1 equal to 0. So equation 8 and equation 9 are framed. Let us employ equation 8 in equation 9. So when you're going to substitute equation 8 in equation 9, I'm going to get I1 equivalent to I2. Okay, when I1 is equivalent to I2, let me treat this equation as 10 and I'll replace I1 equivalent to I2 in equation 8 so that V1 will be equivalent to 2I1. In fact, V1 will be also equivalent to 2I2. Okay, so B is obtained as minus V1 by I2 at V2 equal to 0, whose value will be equivalent to minus 2 ohms. After framing this equation 11, also we can obtain the value of D, which is equal to minus I1 by I2 at V2 equal to 0, whose value will be equal to minus 1. Okay. So after equating all these equations to some numericals, the transmission line parameters, which are nothing but ABCDs, are obtained to be minus 3, minus 2, minus 2, and minus 1. So whatever the approach we have employed in order to obtain the transmission line parameters, is it correct or wrong? Let us cross-examine with another approach. So here we are going to deal with a special case. We are going to inspect this equation with uh, y parameters. For that, I am taking V1 and V2 as nodes because V1 is across 1 ohm and V2 is also across 1 ohm, and there is no other parameters which is connected between inputs and outputs at this stage. So here node V1 is created, node V2 is created, and I'm going to frame the equations with the help of KCL. So I'm going to employ KCL at node 1. So the voltage is V1 and the input current here it is minus I1, I1. It is incoming towards the node. That's why I'm saying as minus for this I1. And you have V1 over here. So the current which is flowing in 1 ohm will be V1 by 1. And the current which is flowing in this particular branch, it will be V1 minus V2 minus 2V1 by 2. And that is the total voltage developed across V1 and V2 divided by the 2 will becomes the branch current. So we are going to employ KCL to this node V1. So we'll get minus I1 plus V1 by 1 plus V1 minus V2 minus 2V1 by 2 equivalent to 0. So that I1 will be equivalent to V1 by 2 minus V2 by 2, and in the Roman letters I have framed this equation as 1. Okay. Similarly, I am going to take the another node V2 and I am going to employ the KCL at this particular node. So when you're going to apply KCL at node 2, you're going to get minus I2 plus V2 by 1. This is the current over this branch. Then you have V2 minus V1 plus 2V1 all divided by 2 equivalent to 0, such that we can get the value of I2, it is equivalent to V1 by 2 plus 3V2 by 2, and this in terms of Roman letters I have created equation 2. Now if at all you carefully observe, I1 is in terms of V1 and V2, I2 is also in terms of V1 and V2. So we can easily obtain the Y parameters whose standard equations are given by I1 and I2 compared with Roman letter I1 and I2. So I'm going to get Y parameters which is equal to 1 by 2 minus 1 by 2. Again you have here 1 by 2 and 3 by 2. So that the Y parameters of this particular circuit or network, we will call this as particular network, which is equivalent to 0.5 minus 0.5. Again you have here 1 by 2 which is 0.5 and 3 by 2 will give you the value as 1.5. Okay, so we have obtained the Y parameters. Now we can convert Y parameters to Z parameters from the delta of Z, that is the delta of Y, in fact Y11 minus y12 and y21. So zero point 0.5 multiplied with 1.5 will give you the value as 0.75. Minus of minus will give you plus, and zero point 0.5 square will give you the value as 0.25. So 0.75 plus 0.25 will give you the value as 1. So delta y value is 1. So 1 divided by delta y, and here you have y22. Here you will be having y11 minus y12 and y21. So similarly, you employ the inverse of this particular equation and you get the value of Z parameters, which is equivalent to 1.5, 0.5, minus zero point 0.5 and zero point 0.5. Please answer in the chat box whether you got the Z parameters with the help of inversion of Y parameters or not. Okay, once we obtain the Z parameters, it is easy for us to convert Z parameters into transmissional parameters with the derivation 1 by Z21 open bracket Z11 delta Z1 and Z22. So I'm going to substitute these values in this frame and I'm going to get the value as minus 3 minus 2 minus 2 minus 1. So if you observe carefully, we have obtained Z parameters, we have obtained Y parameters, and finally the transmission line parameters, which is exactly same what we have employed using the normal approach. So I hope you have understood this particular class of transmission line parameters. Please like and share among your friends, subscribe to this channel, and please press the bell icon for the future notifications. Thank you.